Welcome to Time Before Us, the channel where ancient history breathes again. Before time had a name, before the first human breath, there existed a world fierce, forgotten, and alive. Creatures of scale and silence, predators wrapped in feathers, titans that shook the earth, lives erased, bones buried beneath eternity. But they are not lost, they are waiting. This is Time Before Us, where prehistory worlds rise again, and the stories buried in stone finally speak. Chapter 1. The Misunderstood King. T-Rex. For over a century, Tyrannosaurus rex has towered above the rest of the dinosaur kingdom in the public imagination. It's the undisputed king of pop culture dinosaurs, the ultimate predator, the towering terror with bone-crushing jaws. But here's the twist most people never see coming. Much of what we think we know about T-Rex is either outdated, exaggerated, or flat-out wrong. In reality, T-Rex might be one of the most misunderstood animals in history. Yes, it was a massive predator. Yes, it had terrifying teeth and a bite force unmatched by anything alive today. But it was also intelligent, complex, and surprisingly sophisticated. Forget the lumbering monster you saw in old movies, or even the roaring giant from Jurassic Park. The real T-Rex had a sharp mind, a sensitive snout, and might not have made a sound at all. Let's start with the brain. Despite having a skull over 5 feet long, T-Rex had a brain roughly the size of a human's. But what matters isn't just size, it's structure. Brain scans of fossilized skulls have revealed well-developed olfactory bulbs, indicating an extraordinary sense of smell. Some scientists think T-Rex could smell prey from miles away, tracking it with the patience of a seasoned hunter. Other areas of the brain suggest it had excellent balance, coordination, and perhaps even complex behavior. Then there's its vision. You might think those forward-facing eyes were just for dramatic effect, but they actually gave T-Rex depth perception and sharp eyesight. Recent reconstructions suggest it may have had better vision than modern-day eagles. That means it didn't just rely on smell to find its prey. It could see you coming, even from a long distance. But perhaps the most surprising revelation in recent years involves its snout. The bones in T-Rex's face weren't just for show. They were packed with sensory receptors, similar to those found in modern crocodilians. In other words, its snout was a tool of perception. Some researchers call it a third hand of sorts. It may have used it to delicately nudge eggs, feel out prey, or even engage in mating rituals. Not quite the brutish killing machine you thought it was, huh? Then there's the mystery of its sound. Jurassic Park gave us that unforgettable roar, a thunderous bellow that shook the earth. But in truth, T-Rex probably didn't roar at all. Based on comparisons with modern birds and reptiles, some paleontologists believe it made low-frequency sounds, maybe even infrasonic ones. That means it could have communicated in rumbles too deep for the human ear to hear. Imagine feeling a T-Rex coming before you even heard it. That's more chilling than any Hollywood sound effect. And let's talk about speed. For years, the image of a sprinting T-Rex chasing down a Jeep was iconic. But biomechanics tell a different story. At nearly 9 tons, T-Rex wasn't built for high-speed chases. The stress on its bones would have been immense at running speeds. Most estimates now place its top speed around 12 to 20 miles per hour. Fast, sure, but not marathon runner fast. Instead of chasing prey like a cheetah, it may have relied on ambush tactics, using stealth, vision, and smell to strike. Of course, we can't ignore those arms. The butt of every dinosaur joke. Tiny, awkward, useless looking. Or were they? In truth, those arms were heavily muscled and may have had a purpose. Some scientists suggest they were used to grip prey during feeding or to push themselves off the ground. One theory even proposes that they were adapted for holding onto mates during reproduction. Small? Yes. Useless? Probably not. One of the most hotly debated questions about T-Rex has always been whether it was a predator or a scavenger. For decades, paleontologists argued both sides. But new evidence suggests the answer might be both. Like modern lions or bears, T-Rex was probably an opportunist. If it could hunt, it did. If it found a free meal, even better. And let's be honest, if you were 9 tons of muscle and teeth, who would stop you? More recent fossil discoveries have shed light on social behavior as well. For a long time, T-Rex was pictured as a solitary killer. But trackways and fossil beds suggest it may have traveled in groups, especially as juveniles. That means the terrifying lone monster may have been part of a pack, working together, communicating, and perhaps even caring for young. It doesn't just change how we see T-Rex, it changes how we understand dinosaur behavior as a whole. And speaking of juveniles, here's something most people don't realize. A teenage T-Rex looked dramatically different from the adult. Lighter, faster, with longer legs and more slender jaws. They likely occupied different ecological niches than their elders, targeting smaller prey and staying out of the way of full-grown tyrants. In a way, a single species functioned like multiple predators depending on age. The more we learn, the more T-Rex transforms from a one-note villain into a complex, adaptive, almost majestic creature. It wasn't just a killing machine. It was a living, breathing animal with strengths, weaknesses, and behaviors that continue to surprise even the experts. So, why does this matter? Because T-Rex is more than just a dinosaur. It's a mirror, held up to our understanding of prehistoric life. Every time we revise what we know about it, we revise what we know about evolution, ecology, and the story of life itself. It reminds us that science is never static, that even the most iconic creatures can still hold secrets. So the next time someone says, "It's just a T-Rex," you'll know better. You'll know that behind those teeth and claws was a creature of stunning complexity. A misunderstood king, still revealing his story millions of years later. And we're only getting started. Chapter 2. Velociraptor. Hollywood lied. If there's one dinosaur Hollywood has done dirty, it's Velociraptor. Thanks to blockbuster films, most people picture a human-sized, scaly predator with knife-like claws, hyper-intelligence, and a nasty attitude. But here's the twist. That creature isn't Velociraptor at all. It's a mix of creative liberty, misunderstood science, and cinematic flair. The real Velociraptor was smaller, feathered, and arguably even more fascinating than its movie counterpart, just in a very different way. In truth, Velociraptor was roughly the size of a turkey. That's right, not a lion-sized predator. That could open doors, but a sleek, nimble hunter weighing around 30 pounds and stretching about 6 to 7 feet from snout to tail. Its bones were hollow, its body lightweight, and it was built for speed and agility, not brute strength. And unlike the reptilian depiction on screen, the real Velociraptor was feathered, part of the groundbreaking evidence that firmly links dinosaurs with birds. Paleontologists have found quill knobs on the forearm bones of Velociraptor fossils, the same kind of anchor points that birds use to hold feathers in place. This wasn't just a fluffy coat for show. Feathers may have played roles in thermoregulation, display, or even nesting behavior. Imagine a predator stalking through the late Cretaceous deserts of Mongolia, covered in sleek feathers, glinting under the sun. But despite its small size, Velociraptor was no less formidable. It had a long curved claw on each foot, the famous sickle claw, which it could use to pin down prey. Its jaws were lined with sharp teeth, and its snout was narrow and sensitive, likely helping it identify and track small movements. And its brain, while not as disproportionately large as films suggest, was still advanced compared to many other dinosaurs. It had a keen sense of smell, good vision, and agility that made it a deadly hunter in its own right. Where the myth diverges dramatically is in the depiction of intelligence. Hollywood made Velociraptor the Einstein of the Cretaceous, capable of solving complex problems, coordinating in tactical squads, and showing near-human reasoning. In reality, while raptors likely had decent brain-to-body ratios, they weren't planning ambushes or opening doors. Intelligence in dinosaurs is still a debated topic, and while Velociraptor was no slouch, it wasn't some Jurassic James Bond either. However, one area where science and fiction might converge is the idea of social behavior. There's growing evidence that some dromaeosaurs, the broader group that includes Velociraptor, may have hunted in groups or at least interacted socially. Fossils found in close association suggest they may have lived in pairs or small groups. Whether that was true pack behavior like wolves or more opportunistic feeding, like crocodiles, is still up for debate. Velociraptor's fame also owes a lot to where it was found. Most specimens come from the Gobi Desert in Mongolia, a region that has given paleontology some of its most remarkable treasures. In one legendary fossil, a velociraptor is preserved mid-fight with a Triceratops, its claw embedded in the herbivore's side as both animals were buried suddenly, likely by a collapsing dune. It's a snapshot in time, frozen in combat. And it proves that even small raptors could go after bigger prey if the opportunity presented itself. Another surprising twist? Velociraptor wasn't the only raptor, not even the biggest or the scariest. Its cousin, Utahraptor, was closer in size to the cinematic version, up to 20 feet long and built like a tank. It's possible the filmmakers accidentally modeled their raptors after these larger cousins and simply kept the name that sounded coolest. The real Velociraptor reminds us of how science constantly evolves. What we thought we knew 30 years ago has been rewritten thanks to new discoveries, better technology, and a willingness to update our understanding. And while it might be tempting to cling to the Hollywood version, the truth is far more fascinating. A feathered, fast-moving predator stalking ancient dunes, using its speed and smarts to survive in a harsh, unforgiving world. That's no less impressive than any movie monster. So next time you hear someone say velociraptors were terrifying beasts taller than a man, feel free to remind them, the real creature may have been small, but it was mighty. A misunderstood marvel of evolution, not the monster we imagined, but something far more real, and in many ways, far more remarkable. Velociraptor wasn't the nightmare Hollywood sold us. It was something better. A window into how birds took flight from the ashes of the dinosaurs. Chapter 3. Triceratops. More than just horns. When most people think of Triceratops, they picture a massive, lumbering tank of a dinosaur, with 3 fearsome horns jutting from its face. It's the classic horned dinosaur, the prehistoric rhinoceros of pop culture. But this Cretaceous icon has long been misunderstood. New discoveries have revealed that Triceratops wasn't just a walking fortress. It may have been a surprisingly social animal, one that used its horns and frill for far more than just self-defense. Turns out, the true story of Triceratops is much more nuanced and far more fascinating. Triceratops lived at the very end of the age of dinosaurs, about 68 to 66 million years ago, during the late Cretaceous period. It shared its environment with some of the most famous dinosaurs to ever walk the earth, including the mighty Tyrannosaurus rex. That meant it had to be tough, and it was. Weighing up to 20,000 pounds and stretching nearly 30 feet in length, Triceratops was built like a tank, with strong limbs and a low center of gravity. But it's those iconic horns and massive frill that steal the show. Traditionally, scientists believe these features were primarily for defense. It makes sense. What better way to fend off a T-Rex than with 2 3-foot-long horns above your eyes? But as paleontologists studied more fossils, a different picture started to emerge. Some Triceratops skulls showed signs of healed wounds, bite marks, and punctures that suggest horn-to-horn combat with other Triceratops, not predators. These weren't fatal injuries either. They'd healed, meaning the fights were more like contests than battles for survival. This led to a new theory. Maybe those horns and frills were used for interspecies communication, like how deer or antelope use their antlers. They may have been displays of dominance used in mating rituals, or to establish rank within herds. Some researchers even believe individual Triceratops could recognize one another based on the shape of their frills, which varied slightly from dinosaur to dinosaur. In other words, their frills were like prehistoric name tags or display signs. Look at me, I'm strong, healthy, and ready to lead. Even more surprising is the possibility that Triceratops weren't solitary animals. For years, the assumption was that they lived alone or in small family groups. But recent fossil discoveries in Montana and elsewhere have uncovered bone beds with multiple Triceratops individuals buried together. That suggests at least occasional group behavior. Maybe they moved in herds, at least during certain seasons or stages of life. Maybe juveniles stayed in groups for protection, while adults wandered solo. The possibilities are still being explored. But one thing's clear. Triceratops wasn't necessarily a loner. And speaking of juveniles, baby Triceratops looked a lot different than their adult counterparts. Their horns were shorter, their frills smaller and rounder, and their body proportions more compact. That's led some scientists to believe their horns and frills developed as they aged, not just for protection, but as social signals. Much like peacocks grow fancier feathers or elk develop larger antlers. Their growth stages may have reflected their changing roles in dinosaur society. Another layer of mystery lies in how Triceratops used its massive beak. Like a giant parrot, Triceratops had a powerful curved beak at the front of its mouth. Perfect for shearing through tough vegetation. But new studies of wear patterns on Triceratops' teeth suggest it wasn't just munching on ferns. It may have chewed cycads, palms, and even the tougher, woodier plants of its time, suggesting it had one of the most complex and powerful jaws of any herbivorous dinosaur. Its dental batteries, rows and rows of stacked teeth, were constantly replaced, like a factory conveyor belt of chewing tools. Then there's the debate over whether Triceratops was even its own species. At one point, some scientists proposed that Triceratops and another horned dinosaur, Pterosaurus, were actually the same animal at different ages. The theory went that as Triceratops aged, its frill changed shape and became thinner, eventually transforming into what was known as Pterosaurus. This caused a stir in the paleontology community. But later studies suggested otherwise. Differences in bone structure, frill texture, and fossil distribution pointed to them being separate species after all. It's a reminder that even the most iconic dinosaurs are still subjects of debate, and, of course, no conversation about Triceratops is complete without mentioning its nemesis, Tyrannosaurus rex. Fossil evidence shows that T-Rex and Triceratops likely clashed. Some Triceratops fossils show deep bite marks that match T-Rex jaws, and at least one T-Rex skeleton has healed injuries that may have come from a Triceratops horn. It's a clash of titans, predator and prey locked in a prehistoric arms race, each evolving to counter the other's strengths. That alone is enough to fire the imagination. In the end, what we know about Triceratops is still evolving. New fossils, better tools, and more sophisticated methods are changing our understanding of this dinosaur every year. It wasn't just a slow-moving plant eater with horns. It may have been a social creature, a visual communicator, a surprisingly versatile herbivore, and a rival to one of the fiercest predators of all time. So the next time you see a statue or illustration of Triceratops staring down a T-Rex, don't just think of brute strength or dinosaur duels. Think of a creature that lived in a dynamic world, full of sound, color, movement, and complexity. Think of the nuances hidden in bone and beak, horn and frill. Because sometimes, the most familiar dinosaurs are the ones we've only just begun to understand. Chapter 4. Stegosaurus, the dumb dinosaur. For generations, Stegosaurus was the punchline of the dinosaur world. A creature with a brain the size of a walnut and a body as big as a van. An armored oddity with enormous backplates and a spiked tail that looked more like a Renaissance weapon than a natural limb. In every schoolbook and museum diorama, it stood as a symbol of primitive stupidity. A dinosaur that survived not by wit, but by sheer luck and defense. But as it turns out, that perception was not only unfair, it was flat out wrong. Stegosaurus has always been a showstopper. With its signature double row of kite-shaped plates rising along its spine and a tail armed with 4 lethal spikes, it looks like something a science fiction artist might dream up. It roamed the late Jurassic period, around 150 million years ago, mainly in what is now Western North America. Adults could reach over 30 feet in length and weigh up to 5 tons. For something so heavily armored, it wasn't a predator but a plant eater, chugging through prehistoric forests filled with ferns and cycads. The real controversy begins with that brain. The old claim that Stegosaurus had a brain the size of a walnut? It's based on a misunderstanding. Yes, its brain was relatively small compared to its body, but that's true for many large dinosaurs. Estimates place its brain volume at around 70 to 80 grams, closer in size to a lime. Still small, yes, but not absurdly so. And then there was the infamous idea of a second brain in its hips, a theory that persisted for decades. Paleontologists noticed a large cavity in the sacral region and once proposed that it might have housed a secondary control center to help with reflexes in the rear body. But that theory has since been discarded. That space likely held a glycogen body, a structure found in modern birds that stores energy but doesn't function like a brain. The myth endured because it was just too good a story. But intelligence isn't just about brain size, it's about adaptation. And here, Stegosaurus starts to surprise us. Its backplates, for instance, are a scientific mystery and marvel. Early paleontologists assumed they were armor, meant to ward off predators like Allosaurus. But later studies showed they weren't arranged or structured in a way that would provide much protection. Instead, the plates may have served as a form of thermoregulation, like biological radiators that help the dinosaur manage body heat. The plates had a rich network of blood vessels, implying they could release or absorb heat depending on environmental conditions. Some scientists think they may also have been used for display, signaling dominance, species recognition, or even mating fitness. And speaking of display, that tail wasn't just for balance. It was a weapon. Paleontologists call it the Thagomizer, yes, officially named after a Far Side comic. Each spike could reach over 3 feet long and was likely capable of delivering devastating blows to predators. One Allosaurus fossil shows evidence of a broken rib consistent with a Stegosaurus tail strike. So much for slow and stupid. This dinosaur was armed and dangerous. Its gait and posture were also more advanced than once believed. Early depictions showed Stegosaurus dragging its tail like a lazy lizard. But now we know its tail likely stuck straight out, used for balance and combat. Its forelimbs were shorter than its hind limbs, giving it a sloped back that was once mocked as awkward, but is now understood as part of its locomotion strategy. Even its diet reveals surprises. Stegosaurus didn't just nibble low-lying plants. Its beak-like mouth and peg-shaped teeth suggest it was adapted to strip leaves and soft vegetation, perhaps feeding on cycads, ginkgos, and ferns. Some have proposed it could rear up on its hind legs to reach higher plants, leveraging its powerful hindquarters. That idea, while debated, points to a more versatile feeder than the old model suggested, and maybe most surprisingly, it may not have been a loner. Evidence from fossil sites suggests Stegosaurus may have lived in groups or at least tolerated the presence of others. Tracks show parallel movement, and some bone beds contain multiple individuals, hinting at social behavior. Previously thought unlikely for such a primitive dinosaur. So what we have is a dinosaur that was beautifully adapted for its environment. It wasn't fast, but it didn't need to be. It had built-in defenses, thermal controls, and possibly even social structures. It was an evolutionary specialist in an age filled with threats. Not a genius by modern standards, sure, but calling. It dumb misses the point. Stegosaurus was a survivor. It lived in a time of giants and predators, and it thrived. Not by luck or accident, but because it was perfectly suited to its world. Turns out, the dinosaur we once ridiculed as a brainless brute was, in its own way, brilliant. Just not in the way we expected. And sometimes, that's the most surprising truth of all. Now that we've challenged the old myths about Stegosaurus, are you ready to uncover what made Brachiosaurus a walking biological marvel? Let's keep going. Chapter 5. Brachiosaurus, the high-rise grazer. At first glance, Brachiosaurus looks like the classic gentle giant of the dinosaur world, an enormous, slow-moving plant-eater that towered above everything else in its Jurassic habitat. But behind that long neck and easygoing reputation lies one of the most physiologically fascinating creatures to ever walk the earth. To understand Brachiosaurus is to dive into a story of biological extremes, from sky-high blood pressure to gravity-defying breathing systems. This wasn't just a tall dinosaur. This was a marvel of prehistoric engineering. Brachiosaurus stood out from its long-necked peers for a number of reasons. For starters, its front legs were longer than its hind legs, giving its body a distinctive sloped posture. That upright stance wasn't just for show. It allowed Brachiosaurus to reach higher than most other sauropods. Picture a giraffe that's been stretched out to 80 feet long and over 40 feet tall. The trees that other herbivores grazed under were merely appetizers for Brachiosaurus. It could pluck leaves from the tallest conifers with ease, accessing a buffet of vegetation few others could reach. But here's where things get mind-blowing. Just how did a creature that tall even survive? Think about it. A heart has to pump blood all the way up that elongated neck to the brain. For Brachiosaurus, that meant pumping blood roughly 25 feet straight up. That's a physiological challenge unlike anything seen in modern animals. Some scientists estimate that Brachiosaurus would have needed a heart weighing nearly 900 pounds to get the job done, and it may have had an incredibly high blood pressure, 2 to 3 times greater than that of any living animal today. And then there's the breathing. You might think a neck that long would make it hard to breathe efficiently, and you'd be right, if it weren't for an ingenious adaptation. Brachiosaurus likely had a system of air sacs similar to those found in birds today. These air sacs would have lightened the neck and made breathing more effective by allowing air to flow continuously through the lungs in a unidirectional loop. It wasn't like mammals that breathe in and out. Brachiosaurus had a more sophisticated respiratory system, possibly one of the most advanced of any land animal. It's hard to overstate how much this changes the picture of this dinosaur. This wasn't a lumbering, dim-witted beast. This was a high-performance biological machine, fine-tuned over millions of years. That long neck wasn't just for show. It was part of a complex system that let Brachiosaurus dominate its ecological niche. And yet, for all its size and grandeur, Brachiosaurus may have been surprisingly vulnerable. Predators like Allosaurus likely wouldn't have taken down a healthy adult, but juveniles would have been fair game. Their size was both an asset and a liability. They needed vast amounts of food and space to survive. A single adult Brachiosaurus may have needed to eat hundreds of pounds of plant material a day. And that raised another question: how did it feed efficiently? It turns out that Brachiosaurus may not have chewed much at all. Like many sauropods, it likely snipped leaves and swallowed them whole. Instead of chewing, it relied on gastroliths, stone swallowed, to help grind up food in its stomach. The digestive process was slow and steady, a factory line of fermentation and breakdown that turned rough foliage into the energy needed to power its massive frame. Social behavior in Brachiosaurus remains speculative, but some fossil sites suggest that sauropods may have traveled in herds, possibly for protection or migration. Imagine a group of these giants moving through Jurassic forests, their heads swaying above the treetops like mobile towers. The ground would tremble beneath them. Their sheer presence would reshape the landscape. And speaking of landscapes, Brachiosaurus lived in what is now North America. During the late Jurassic period, around 154 to 153 million years ago. The Morrison Formation, a vast rock unit stretching across several states, is where many of its fossils have been found. This region was warm, semi-arid, and dotted with river systems, forests, and floodplains. Brachiosaurus wasn't the only giant around. It shared its world with other sauropods like Diplodocus and Camarasaurus, as well as theropods like Allosaurus. But it held its own, literally towering over the rest. Cinematic depictions have always loved Brachiosaurus. Who could forget the iconic moment in Jurassic Park when it reared up to feed on a tall tree, its long neck stretching skyward, set to that unforgettable John Williams score? That scene captured something primal, the awe of seeing something so massive, so otherworldly, yet grounded in scientific possibility. But of course, Hollywood took a few liberties. Real Brachiosaurus likely didn't rear up like a horse. Its body wasn't built for that kind of movement. Still, the majesty remains. Despite its fame, Brachiosaurus has also been a source of taxonomic confusion. For years, the well-known specimen in museums, particularly the one in Berlin, was actually a close relative called Giraffatitan. The two were once lumped together, but are now considered separate genera. It's a reminder that even the most familiar dinosaurs are still subject to revision as science progresses. Brachiosaurus is a testament to the extremes life can reach when given time, space, and the right evolutionary pressures. It was a skyscraper on legs, an herbivorous colossus that turned physiology on its head. And while its skeleton might look serene and static in museums, remember that in life, it was anything but. It breathed like a bird, pumped blood like a hydraulic system, and lived in a world full of wonder and danger. When you picture the age of dinosaurs, it's often the image of Brachiosaurus, head high in the clouds, that comes to mind. And for good reason. It represents the grandeur of the Jurassic, the incredible adaptations of sauropods, and the mysteries that still remain. Because Brachiosaurus wasn't just a long-necked dinosaur. It was an evolutionary masterpiece. A creature that defied expectations, rewrote the rules of biology, and soared, quite literally, above the rest. Chapter 6. Spinosaurus, the water hunter for decades. Spinosaurus was a dinosaur that barely got more than a footnote in textbooks. It was a shadowy figure described in the early 1900s, but mostly known from vague sketches and a few broken bones. Those bones? Destroyed in a bombing raid during World War II. For over half a century, Spinosaurus remained a mystery. But when paleontologists finally started unearthing new fossils in North Africa, what they found wasn't just surprising. It was completely groundbreaking that this dinosaur didn't just challenge our expectations. It upended them. Spinosaurus wasn't some land-stalking predator like T-Rex or Allosaurus. It looked like a chimera, a bizarre mix of crocodile, heron, and sailboat. For starters, it had a long, narrow snout filled with conical teeth, perfect for gripping slippery fish, not tearing flesh. Its nostrils were high on its snout, suggesting it could breathe while most of its head was underwater. Add to that the giant sail on its back, and you have one of the most unusual dinosaurs ever discovered. But the real shock came in 2014, when researchers unveiled new fossil material from Morocco. Among the bones was a long, flat tail one shaped less like a dinosaur's and more like a giant paddle. That tail, combined with short hind limbs, dense bones, and a center of gravity closer to the front of its body, strongly pointed to one radical idea. Spinosaurus may have been semi-aquatic. That's right, not just a dinosaur that hunted near rivers. A dinosaur that swam in them. This changed everything. Up to that point, paleontologists had assumed dinosaurs were strictly land animals. The seas? Those belonged to ichthyosaurs, plesiosaurs, and mosasaurs. But Spinosaurus didn't play by the rules. It had evolved to hunt. Underwater, possibly stalking massive fish like coelacanths and sawfish in prehistoric river systems that crisscrossed what is now the Sahara Desert. And yes, it really was a desert back then. But not the kind we know today. During the Cretaceous, this part of North Africa was a lush tropical swamp teeming with life. A perfect place for a 50-foot-long, fish-hunting predator to thrive. The sail on its back? That's still a bit of a mystery. Some scientists think it helped regulate body temperature. Others believe it was purely for show, a flashy ornament used to attract mates or intimidate rivals. There's even a theory that it helped Spinosaurus appear larger to aquatic prey, a bit like a fishing lure. Whatever its purpose, one thing is clear: it made Spinosaurus look like something out of a science fiction movie. But it's not fiction. It's real. And it's changing how we think about what dinosaurs could be. Spinosaurus didn't just walk a different path. It swam one. In a world dominated by land-based titans, it charted a course into the water, carving out an entirely new ecological niche. That makes it one of the most important and most misunderstood dinosaurs of all time. Its discovery tells us something deeper too. Our picture of dinosaurs is still evolving. With every new fossil, we uncover not just bones, but entire worlds we never imagined. Spinosaurus is a reminder that the story of dinosaurs isn't set in stone. It's still being written. And sometimes, it takes a sail-backed, crocodile-snouted swimmer to show us just how much we've yet to learn. Chapter 7. Ankylosaurus. The living tank. Ankylosaurus is often called the armored tank of the dinosaur world, and once you take a look at it, it's easy to see why. But to stop at just calling it a walking tank is to overlook one of the most fascinating and misunderstood dinosaurs of the Cretaceous period. Sure, it had armor. Yes, it had a club at the end of its tail that could shatter bone. But beneath that tough exterior was a dinosaur built with surprising nuance, and possibly even some clever biological hacks that helped it thrive in a world of predators. First, let's paint the picture. Ankylosaurus was built low to the ground, four-legged and solid. Its entire body was covered in thick, bony plates called osteoderms, embedded in its skin like a suit of medieval armor. From the top of its head to the tip of its tail, this dinosaur was clad in defensive structures that made it nearly impervious to attack. Think of it as nature's answer to a tank combined with a fortress. The sheer toughness of its hide meant that even the fiercest predators like Tyrannosaurus rex would have thought twice before trying to make a meal of it. But the armor wasn't its only defense. Ankylosaurus wielded one of the most iconic weapons in dinosaur history, the tail club. This was no ordinary tail. It was a stiff, bony rod ending in a massive, hammer-like knob of fused bone. Scientists believe that this club wasn't just for show. It could deliver devastating blows strong enough to break bones, maybe even the legs of a charging predator. Fossil reconstructions show strong tendons and musculature running through the tail, suggesting it could swing with precision and force. Some estimates suggest that the force of a tail club strike from an Ankylosaurus could reach over 4,000 newtons more. That's enough to cause serious injury to any predator foolish enough to come too close. Now, here's something you may not have expected. Ankylosaurus may have had built-in air filters. Its nasal passages were incredibly complex, long and looping, almost like a maze. At first, paleontologists were puzzled. Why would a slow-moving, herbivorous dinosaur need such complicated nasal plumbing? One possibility is that these convoluted airways helped warm and moisten the air it breathed, much like the turbinates in modern mammals. Another theory is that it helped Ankylosaurus detect scents better, or perhaps regulate its body temperature. Some have even speculated that these nasal structures allowed it to produce low-frequency sounds to communicate, like the infrasonic rumbles of elephants. Imagine that, a rumbling tank of a dinosaur, broadcasting its presence across the plains. Recent 3D scans of Ankylosaurus skulls have revealed that the nasal passages loop and coil in a way that suggests both complex airflow and potential acoustic functions. This means Ankylosaurus might not have been a silent creature. It could have communicated using deep, resonant rumbles that traveled long distances, especially useful in dense forests or low-light environments where visual signals were less effective. Despite its heavy armor, Ankylosaurus wasn't sluggish. Its limbs were short but strong, built to carry its massive weight and navigate tough terrain. Its feet were broad, which helped spread out its weight, kind of like snowshoes, but for a creature that weighed nearly 8,000 pounds. And while it wasn't fast, speed wasn't the point, defense was. It didn't need to run. It just needed to endure, to resist, to survive. Its strength was in its presence. Its small leaf-shaped teeth and relatively weak bite force suggest it was a low grazer, feeding on ferns, low shrubs, and possibly cycads. But the way its head and body were built suggests it could process tough plant matter efficiently. It had a large gut, likely housing bacteria to help break down cellulose-rich plants. Think of it as a walking compost machine, slow but efficient. Its digestive system was likely specialized to handle a high-fiber, low-nutrient diet that would have posed a challenge for many other herbivores. Ankylosaurus was also likely solitary, or maybe moved in loose groups. It didn't need the safety of numbers. Its armor was its security, but that doesn't mean it wasn't aware of danger. Its eyes were set on the sides of its head, giving it a wide field of vision to spot threats. Some studies suggest that its hearing wasn't particularly sharp, but its sense of smell might have been well developed, helping it track food or even recognize the scent of other ankylosaurs. That broad snout might have acted like a biological vacuum cleaner, sweeping the forest floor for the choicest bits of vegetation. And what about its enemies? The most famous contender is the Rex, which lived at the same time and place. A clash between these two giants would have been like a prehistoric tank battle. Could T-Rex bite through the armor? Maybe, if it struck the right spot. But that tail club, that could shatter bones. There are no confirmed fossils showing that T-Rex injured by an Ankylosaurus, but the potential was there. A strategic tail strike could turn the tide of an ambush, one swing to the leg or rib cage, and the hunter could quickly become the hunted. Interestingly, some paleontologists suggest that the tail club might have had functions beyond combat. It could have been used in mating displays or to establish dominance over rivals. After all, not all threats come from predators. Sometimes, competition comes from within the species. An impressively large or well-used tail club might have signaled strength, health, and fitness, essentially acting as a prehistoric resume during mating season. And then there's the question of how Ankylosaurus evolved. Its lineage, the Ankylosauridae, spans millions of years and includes many armored relatives across the globe. From the spiny nodosaurs to the more heavily armored Euplocephalus, the family tree of ankylosaurs is a testament to evolutionary experimentation. Ankylosaurus itself was one of the last and largest members of this lineage, representing the peak of armored adaptation. Despite its heavy protection, Ankylosaurus eventually met the same fate as all non-avian dinosaurs at the end of the Cretaceous. Still, its fossilized remains continue to amaze scientists, not just for their toughness, but for the hints they give us about behavior, biology, and evolution. It's a dinosaur that makes us rethink what it means to be strong. Not just brutish, aggressive strength, but a calm, steady, quiet kind of strength. The kind that endures. Ankylosaurus wasn't just a tank. It was a marvel of natural engineering, a survival machine with hidden complexities. It had evolved not only to defend, but to adapt, to sense, to communicate. It didn't chase glory on the battlefield, it simply dared anything to test its armor. The next time you see a picture of this armored beast, look past the club and the plates. Think about the nasal airways, the defensive strategies, the plant processing gut, and the quiet confidence of a creature that didn't run from danger. It stood its ground and won. Chapter 8. Allosaurus, the forgotten apex. When people think of apex predators from the age of dinosaurs, one name dominates the conversation: Tyrannosaurus rex. Its bone-crushing bite, towering size, and pop culture fame have made it a household name. But long before T-Rex ever stalked the earth, another predator reigned supreme, one just as fierce, just as important, but often overlooked: Allosaurus. This carnivorous dinosaur lived during the late Jurassic period, around 155 to 145 million years ago, and in its time, it was the undisputed top predator. A master hunter, a strategic killer, and a fascinating creature of science, Allosaurus deserves to step out of the shadows of its more famous relatives. Allosaurus wasn't just big, it was agile too. It measured up to 30 feet long, with powerful hind legs built for running and long arms equipped with 3 razor-sharp claws. Unlike the two-fingered T-Rex, Allosaurus had flexibility and range in its grasp. Its skull was lighter than many other theropods, featuring dozens of serrated teeth curved backward, perfect for gripping and tearing flesh. But perhaps the most interesting feature of its skull was the pair of bony ridges above its eyes. These might have protected its eyes during fights or served as visual displays to communicate with others. But what really sets Allosaurus apart isn't just its anatomy, it's how it likely hunted. Some paleontologists believe Allosaurus used a technique called the hatchet attack. Its skull was lightly built but incredibly strong, supported by powerful neck muscles. This may have allowed it to swing its head downward like an axe, slashing open the flesh of its prey with each strike of its serrated teeth. Unlike the bone-crushing bite of a T-Rex, Allosaurus may have relied more on slicing than crushing, delivering repeated wounds that weakened prey until it could finish the job. In a way, it fought less like a lion and more like a wolf with blades for teeth. And here's where things get even more interesting. Allosaurus may have hunted in groups. Fossil beds like the famous Cleveland Lloyd dinosaur quarry in Utah contain an unusually high number of Allosaurus remains. Some scientists interpret this as evidence of social behavior. Maybe these predators worked together to take down massive herbivores like Camarasaurus and Diplodocus, prey much larger than a single Allosaurus could handle alone. Of course, it's also possible these sites represent a predator trap, a place where animals got stuck and died one after another. But the group hunting theory has captured the imagination of many. Even if Allosaurus wasn't a pack hunter, it was still a terrifying solo predator. Its legs were built for speed, allowing it to chase prey across open plains. And while it may not have had the bone-shattering bite of later theropods, it made up for it in tactics, agility, and persistence. Allosaurus was the apex predator of its time, the king of the Jurassic. Long before T-Rex was even a glimmer in evolution's eye, the ecosystems Allosaurus roamed were teeming with life. Towering sauropods stretched to the treetops, herds of Stegosaurs shuffled through the underbrush, and pterosaurs circled in the skies above. Allosaurus had to navigate a complex environment, hunting amidst giants. Fossilized bones show healed injuries, suggesting it lived through brutal encounters. One specimen shows signs of a broken rib and bite marks, wounds that eventually healed. This was a survivor, a fighter, a creature that didn't back down easily. But even the king can fall. By the end of the Jurassic period, Allosaurus and its kin were replaced by newer, larger predators as the Cretaceous period began. But their legacy remained, and their fossils became some of the most commonly found in North America. In fact, Allosaurus was one of the first theropods to be thoroughly studied. It's sometimes called the Lion of the Jurassic, and for good reason. It combined raw power with deadly precision, yet despite its significance, Allosaurus doesn't get the fame it deserves. It's often left in the background, a footnote to the larger, flashier theropods that came later. But if we peel back the layers of time, we find a predator that was every bit as impressive. A dinosaur that ruled its world with cunning and strength. So the next time someone mentions T-Rex as the ultimate predator, you can nod politely. And then tell them about Allosaurus, the forgotten apex that carved out its legacy millions of years earlier. Chapter 9. Parasaurolophus. The musical Mr. Parasaurolophus is one of those dinosaurs that leaves a lasting impression, not because of claws or teeth or sheer size, but because of the incredible crest stretching back from the top of its head. It's the kind of dinosaur that, even if you don't know its name, you remember its silhouette. That curved, backward-pointing crest has mystified paleontologists for decades. But recent research is revealing that this dinosaur was not only visually stunning, it may have been one of the most acoustically advanced animals of its time. At first glance, Parasaurolophus looks like a typical duck-billed dinosaur, a drosaur. Like others in its family, it was a plant eater, likely moving in herds, using its flat, grinding teeth to munch through ferns, conifers, and flowering plants. But the moment you see that crest, you realize this is not just another face in the crowd. The crest was not for combat. It wasn't for defense. And it wasn't just for show, although it might have helped with that. The real magic of the Parasaurolophus crest lies inside it. CT scans of fossilized skulls have shown that the crest is hollow, containing a series of intricate, looping chambers. Think of it as a built-in musical instrument. When air passed through the nostrils and into the crest, it could resonate, producing sound. In fact, scientists have digitally reconstructed what these calls might have sounded like. The result? A deep, haunting, almost foghorn-like tone that could travel for miles. But why would a dinosaur need to make such sounds? Communication. In the vast plains and forests of the late Cretaceous, being able to send a signal over long distances could mean the difference between life and death. Imagine a herd scattered over a large area. A Parasaurolophus call could alert others to danger, signal location, or even attract mates. The size and shape of the crest also varied by age and likely by sex, meaning each individual may have had a slightly different tone. This wasn't just a dinosaur, it was a walking brass section. The more we study hadrosaurs, the more we realize how socially complex they might have been. Parasaurolophus, in particular, gives us clues that these dinosaurs weren't just passive plant eaters. They were social, vocal, and maybe even highly intelligent by dinosaur standards. Their eyes were positioned on the sides of their heads, giving them a wide field of vision, ideal for spotting predators while grazing. Their herding behavior might have helped protect the young, with adults forming defensive rings or stampeding to drive off carnivores. And let's not forget the sheer elegance of the Parasaurolophus's design. Unlike heavily armored dinosaurs or fearsome predators, this was a dinosaur built for efficiency. Its limbs were strong but not bulky, suggesting it could walk comfortably on all fours while feeding, but also rear up and run on two legs if needed. It wasn't slow, it wasn't helpless. It was agile, aware, and acoustically connected to its world. Parasaurolophus fossils have been found in North America, especially in what is now Alberta, New Mexico, and Utah. These areas were once part of a lush, river-filled landscape, perfect grazing ground for large herbivores. It's likely Parasaurolophus shared this environment with other hadrosaurs, ceratopsians like Triceratops, and apex predators like Tyrannosaurus rex. But it stood apart, not just in form, but in sound. Even juvenile Parasaurolophus had crests, though much smaller, which adds another layer to the mystery. This wasn't just a trait for attracting mates. It was integral to their identity from a young age. Some paleontologists believe the crest helped young dinosaurs communicate with their parents, staying close in the tall grasses and thick forests. It may have helped them identify each other in crowded environments. Imagine a parent and juvenile calling back and forth, their tones just different enough to be recognized through a sea of similar-looking creatures. There's also speculation about seasonal behavior. Could Parasaurolophus have migrated, using their vocal calls to maintain cohesion across long distances? Some researchers think it's possible. If these dinosaurs traveled in large herds across different environments, sound would have been a critical tool, not just for daily communication, but for survival over time and terrain. Interestingly, the internal structure of the crest may have had a cooling function too. As air passed through the tubes, it might have cooled the blood vessels nearby, acting as a kind of natural air conditioning unit. It's another example of how evolution doesn't waste space. Every twist and turn in the Parasaurolophus's anatomy likely served multiple purposes, and while the crest is what grabs attention, there's more subtlety in Parasaurolophus's skeleton. Its beak was flat, but behind that was a battery of hundreds of tightly packed teeth designed to grind tough vegetation. As teeth wore down, new ones moved in from the back of the jaw. It was like a conveyor belt, always ready to process the next mouthful. This suggests not only a varied diet, but a sophisticated digestive system to handle it. One of the more captivating things about Parasaurolophus is how it bridges the ancient with the modern. Birds, after all, are descended from dinosaurs, and while Parasaurolophus wasn't in the bird lineage, its use of sound, display structures, and possible social behavior make it feel familiar. You can't help but think of cranes, peacocks, or even elephants, all animals that use sound and display to shape their world. In many ways, Parasaurolophus challenges what we think dinosaurs were like. It wasn't terrifying, but it was remarkable. It didn't roar, it sang. It didn't need claws or teeth to make its mark. It used resonance, design, and presence. It's a reminder that not all dominance comes from force. Sometimes it comes from being heard. So the next time you imagine the age of dinosaurs, don't just picture the roaring tyrants or the towering sauropods. Listen, in your mind. Hear that deep, sonorous call echoing through ancient forests. A voice from 75 million years ago, reminding us that even in prehistory, there was music in the wild. Chapter 10, The Truth About Dinosaurs and Birds. It's one of the greatest scientific revelations of the past century, and yet, somehow most people still don't believe it. Dinosaurs never truly went extinct. Well, some of them did. The colossal ground-shaking giants, yes. The toothy tyrants, the frilled and horned herbivores, the sail-backed oddities, they're all gone. But one branch of the dinosaur family tree survived the cataclysm that ended the Cretaceous. And it didn't just survive. It thrived. Today, we call them birds. That's right. When you look at a robin in your backyard, or a pigeon on the street, or even an eagle soaring across the sky, you're looking at a living dinosaur, not their descendant, not their distant cousin. A real, scientifically classified dinosaur. And that changes everything we thought we knew about extinction, evolution, and what it means to be a dinosaur. This astonishing link between birds and dinosaurs wasn't obvious at first. For a long time, paleontologists saw dinosaurs as cold-blooded, scaly, lumbering reptiles, more like giant lizards than anything we know today. Birds, by contrast, were warm-blooded, feathered, agile creatures of the skies. How could they possibly be related? The answer was hidden in the bones. Fossil after fossil began to reveal surprising similarities between theropod dinosaurs, like Velociraptor, Trudon, and even T-Rex and modern birds. They shared hollow bones, a wishbone, furcula, three-fingered hands, and even a backward-facing pubis bone in the hip. And then came the real game-changer, Feathers. In the 1990s, a series of mind-blowing fossil discoveries from China unearthed perfectly preserved feathered dinosaurs. Creatures like Sinosauropteryx and Microraptor had not just quill-like filaments, but fully developed flight feathers on their arms and tails. Some even had wings. These weren't birds. They were unmistakably dinosaurs with claws, teeth, and tails. And yet, they were also undeniably bird-like. The line was starting to blur. As more discoveries rolled in, the evidence became undeniable. Archaeopteryx, long thought of as the first bird, was now seen as just one of many feathered dinosaurs experimenting with flight. And more importantly, modern birds weren't a separate offshoot. They were the surviving branch of a much larger group of feathered theropods. In taxonomic terms, birds are dinosaurs. They fall within the clade Aviale, which itself nests within the larger group of Theropods. This realization is more than a curiosity. It fundamentally reshapes our understanding of both past and present. It means that dinosaurs didn't entirely vanish 66 million years ago. They adapted, survived, and evolved into one of the most diverse groups of animals on Earth today. From hummingbirds to ostriches, parrots to penguins, these are the dinosaurs of the modern world. And they carry the legacy of their ancestors in every flap of their wings. Think about it. The strong chest muscles used for flight? Those evolved from theropods' powerful forelimbs. The beak? A modified snout, shedding teeth in favor of lighter, more specialized feeding tools. Even the way birds lay eggs and care for their young reflects nesting behaviors seen in non-avian dinosaurs like Oviraptor and Truden. Some scientists have even drawn connections between bird songs and the vocalizations of their ancestors. Could dinosaurs sing? Maybe not in the melodic way birds do today, but there's growing evidence that many theropods had complex vocal abilities, perhaps honks, coos, or low-frequency rumbles to communicate across distances. This new perspective also casts a different light on extinction. The asteroid impact at the end of the Cretaceous didn't wipe out all life. It triggered a mass extinction that ended the reign of the giant dinosaurs, but it left a few survivors clinging to the edges, small, lightweight, feathered creatures that could adapt quickly and exploit new niches. In the smoldering aftermath, these bird dinosaurs spread and diversified, filling ecological roles left empty by their fallen kin. It's humbling to realize that, while T-Rex is long gone, the same lineage still thrives in the flutter of a sparrow or the piercing eyes of a hawk. So next time you see a bird, any bird, pause for a second. Picture its ancestors stalking through the underbrush, flapping their proto-wings, or leaping from tree to tree in a dense Jurassic forest. Imagine the evolutionary journey that led from dinosaur claws to tiny toes gripping a telephone wire. Birds are living, breathing reminders that the age of dinosaurs never really ended. It simply evolved. And if we're still sharing the planet with dinosaurs, maybe we've underestimated what extinction really means. Chapter 11. Allosaurus, the forgotten apex. When you think of apex predators from the age of dinosaurs, one name usually dominates the conversation: Tyrannosaurus rex. But millions of years before T-Rex ever walked the earth, there was another killer at the top of the food chain: Allosaurus. Sleek, deadly, and far more nuanced than its nickname, the Butcher, might suggest. Allosaurus has long lived in the shadow of more famous predators. But this Jurassic carnivore was no understudy. It was a star in its own right. Allosaurus thrived around 150 million years ago during the late Jurassic period. It roamed what is now North America and possibly parts of Europe and Africa, dominating a world that looked vastly different from the one T-Rex inherited tens of millions of years later. Picture a land teeming with long-necked sauropods like Diplodocus and Camarasaurus, and armored dinosaurs like Stegosaurus. This was the kingdom of Allosaurus, a predator perfectly adapted to take on giants. At roughly 28 feet long and weighing about 2 tons, Allosaurus was built for hunting. It didn't rely on brute strength alone. Its body was surprisingly lightweight for a large theropod, with hollow bones that kept it agile and fast. Unlike the heavy, crushing jaws of T-Rex, Allosaurus had a narrower skull and blade-like teeth perfect for slicing rather than pulverizing. Some paleontologists even think it used its skull like a hatchet, swinging it downward to slash open prey in a methodical, almost surgical fashion. Its neck was flexible, and it could open its jaws remarkably wide, possibly wider than a crocodile. This might have helped it get a better grip on prey or deliver precise bone-slicing bites. And those arms? While not as massive as T-Rex's famously tiny forelimbs, Allosaurus had decently sized arms with three-fingered hands tipped with large, curved claws. These claws weren't just for show. They may have been essential tools in grappling prey or tearing into carcasses. But what really set Allosaurus apart was its brain. It had a relatively large brain-to-body ratio for its time, especially in areas associated with vision and balance. That suggests it was a smart, active predator. It could track movement, react quickly, and possibly even coordinate with others. There's some fossil evidence, like multiple Allosaurus remains near the same sauropod carcass, that hints at possible pack behavior. Imagine a coordinated group of Allosaurs bringing down a much larger dinosaur together. It's a terrifying and impressive thought. That said, not all scientists agree. Some argue that what looks like group behavior might just be a bunch of hungry dinosaurs converging on an easy meal. It's a debate still unfolding, but even the possibility opens up a new dimension to Allosaurus's story. Its bite force wasn't as powerful as T-Rex's, but that didn't make it any less deadly. Allosaurus may have used a slash-and-let-bleed tactic, making repeated attacks to wear down prey over time. This kind of strategy would have worked well on large sauropods, which were too big to take down with a single strike. A wounded, bleeding animal would slow down, weaken, and eventually fall, making it an easier kill. Some scientists believe Allosaurus may have had a tough time dealing with the dense bones of large prey. Its teeth were sharp, but they weren't built for crunching. Instead, Allosaurus' teeth were more like steak knives, long and serrated, ideal for slicing through flesh. They even show signs of frequent breakage and regrowth, suggesting that biting into big, thrashing prey came at a cost, and it wasn't just brute skill that kept Allosaurus on top. Its eyes were positioned somewhat forward on its skull, giving it partial binocular vision. That's rare in theropods of the time and may have helped it judge distance more accurately, a crucial skill when lunging at moving prey. Allosaurus also had to compete with other carnivores of its time, like Ceratosaurus and Torvosaurus. But it seems to have occupied a different niche, possibly taking down larger prey, while its rivals focused on smaller animals or scavenging. This division of labor may have helped them all coexist in the same ecosystem. Then there's the mystery of the crests. Allosaurus had small, bony ridges above its eyes. They weren't horns or weapons, so what were they for? Some scientists think they helped with species recognition or were used in mating displays. Others suggest they may have shielded the eyes from sunlight. Whatever the reason, they add a unique touch to this already distinctive predator. Did. So the next time you hear about dinosaur kings and prehistoric battles, don't forget Allosaurus. It was fast, it was fierce, and it was one of the most successful predators of its time. In many ways, it set the blueprint for the killers. That came after a dot, and while it may not have the pop culture clout of a T-Rex in the fossil record, Allosaurus stands tall as a true apex of the Jurassic World. Chapter 12. The swimmer with killer claws. Imagine a dinosaur with the claws of a raptor, the snout of a crocodile, and the lifestyle of a fisherman. That's no science fiction mashup. That's baryonyx, one of the most unique predators of the early Cretaceous period. At first glance, it doesn't fit into the typical image of a dinosaur. It doesn't tower like a Tyrannosaurus, nor does It have the sweeping grace of a velociraptor. But what it does have is something far stranger. Adaptations that point to a life spent not just stalking land-dwelling prey, but also diving into a world that dinosaurs rarely explored, the water. When Baryonyx was first discovered in England in the 1980s, paleontologists were stunned. Its 10-inch-long, curved claw was the first thing to capture attention, a sickle-shaped weapon that looked capable of slicing through flesh or grabbing slippery prey. But what followed was even more surprising. Its long, narrow jaws were filled with more than 60 tightly packed, cone-shaped teeth, the kind you'd expect from a fish-eating animal, not a classic meat shredder like an Allosaurus. Its snout resembled that of a modern crocodile, complete with a kink near the end, possibly helping it grip wriggling prey. Fossils of fish scales found in its stomach area sealed the deal. Baryonyx, it turns out, liked to fish, but this wasn't just a dinosaur with odd teeth. The more scientists learned, the more they began to realize Baryonyx was part of an entire group, the Spinosaurids, that may have specialized in a semi-aquatic lifestyle. That notion shattered previous assumptions. For decades, dinosaurs were seen strictly as land animals. Even those that lived near rivers and lakes were assumed to drink from the shore, not plunge in after a meal. But Baryonyx changed the narrative. It likely waded into shallow water to snatch up fish like a prehistoric heron, albeit one weighing over a ton and armed with claws that could tear flesh. And those claws weren't just for fishing. While fish may have made up a big part of its diet, Baryonyx probably wasn't picky. With strong forelimbs and those signature claws, it could have tackled small to medium-sized dinosaurs, scavenged carcasses, or even hunted opportunistically when the moment was right. Its combination of a long neck and long arms gave it reach, while its narrow skull helped reduce water resistance, another aquatic-friendly feature. But how aquatic was it, really? This question has led to one of the most debated topics in dinosaur science. Some paleontologists suggest Baryonyx could swim or dive, while others believe it was more of a shoreline predator. Evidence from its limb bones suggests it wasn't as fully aquatic as later spinosaurids like Spinosaurus, which shows even more extreme adaptations. Still, Baryonyx likely spent far more time near and in water than any typical theropod. It's worth noting that another member of the Spinosaurid family, Suchomimus, shares many of the same traits and may have filled a similar niche in what is now Africa. The two dinosaurs weren't identical, but their similarities hint at a broader evolutionary trend, one where certain theropods began trading dry land for riverbanks and lake shores. In fact, some Spinosaurids may have even had webbed feet or denser bones for ballast while swimming, though these adaptations are more clearly seen in Spinosaurus than in Baryonyx. And what about the claws? Some theories suggest they were used like fishing hooks, stabbing into fish or sweeping them from the water. Others think they were multifunctional tools, for defense, for digging, for pulling prey closer. It's the kind of anatomical feature that invites 1,000 questions and only a few answers. What we do know is this: they were strong, curved, and backed by powerful muscles. Whether grabbing prey or warding off rivals, they were tools no predator would take lightly. Baryonyx also has a claim to fame in pop culture, though like many dinosaurs, it's often misrepresented. Some depictions show it as a simple carnivore, just another sharp-toothed hunter in a prehistoric world. But the real animal was far more specialized and, arguably, far more interesting. It straddled two worlds, land and water, and did so with a body tailor-made for the challenge. Its discovery also challenged the assumptions of paleontology itself. For decades, dinosaurs were boxed into categories: meat eaters versus plant eaters, land dwellers versus sea creatures, fast runners versus sluggish giants. But Baryonyx didn't fit neatly into any of those boxes. It made scientists rethink the boundaries of what dinosaurs could be. If one group of theropods could adapt to an aquatic lifestyle, what else might they have done? What other niches might have been filled by these ancient animals? The baryonyx specimen found in Surrey, England, remains one of the most complete spinosaurid fossils ever unearthed, offering a rare glimpse into a transitional creature, one that doesn't conform to our classic images of dinosaurs. It didn't dominate the land like T-Rex or soar through the skies like a pterosaur. Instead, it crept along riverbanks, eyes scanning the water, claws poised, jaws ready to strike. It was a predator of patience and precision. In a world where survival often meant being bigger, faster, or meaner, baryonyx found success by being different. Its oddities weren't drawbacks, they were advantages. Its crocodile-like snout, its fish-grabbing claws, its long arms, all of them, contributed to a hunting strategy as effective as it was unexpected. So the next time someone tells you all dinosaurs were lumbering beasts of land and thunder, remind them of baryonyx, the swimmer with killer claws, the quiet stalker of the shallows, the dinosaur that proved sometimes being strange is the smartest move of all. Chapter 13. The double-crusted mystery. For decades, the name Dilophosaurus has conjured up one image for many people: a small, frilled dinosaur that spits venom thanks to a certain blockbuster film. But in truth, the real Dilophosaurus was neither tiny, nor frilled, nor venomous. What it was, however, is something far more fascinating: a lanky, fast-moving predator with twin crests on its head that continue to mystify paleontologists to this day. Dilophosaurus lived around 193 million years ago, during the early Jurassic period, a time when dinosaurs were just starting to take over the planet. At about 20 feet long and weighing around 800 pounds, it was no lightweight. It had long, slender legs that suggest it could run at considerable speed, and sharp, curved claws that made it a capable predator. Its skull was narrow but lengthy, with a kink near the front that gave it a distinctive profile. And of course, there were the crests, two thin, curved ridges that ran along the top of its head like a natural crown. Now here's where the mystery deepens. These crests weren't thick or sturdy, they were delicate, almost fragile. They wouldn't have been useful in a fight or for defense. So why did Dilophosaurus have them? One popular theory is that they were used for display, possibly to attract mates or intimidate rivals. In that sense, the crests might be the dinosaur equivalent of a peacock's tail, more about show than function. Some scientists even think they could have been brightly colored, though no direct evidence survives. Another intriguing theory? The crests may have helped regulate body temperature. Just like the ears of a jackrabbit or the plates of a Stegosaurus, the crests might have had blood vessels running through them to release heat. It's speculative, sure, but it shows how multi-purpose and complex dinosaur anatomy can be. Idea that Dilophosaurus spat venom is pure fiction. No fossils suggest any venom glands or delivery systems like grooved teeth. And that neck frill made famous in the movies? Also fake. There's no evidence it ever had anything like that. But the misconception stuck, overshadowing the real animal's biological marvels. The actual Dilophosaurus deserves attention not for what Hollywood imagined, but for what it truly was: a fast, agile, mysterious predator unlike anything else. In its environment, its fossil record tells a story that is still unfolding. The original Dilophosaurus bones discovered in Arizona in the 1940s were poorly understood for decades. For a long time, scientists misclassified it, confusing it with other theropods. It wasn't until years later that researchers realized just how unique its anatomy really was. Recent reanalysis of its fossils has revealed it had a surprisingly lightweight build for its size, and that its jaw may not have been strong enough for tackling large prey. That suggests Dilophosaurus may have used a combination of ambush and speed to take down smaller animals or scavenged more than it hunted. Another striking feature is its hollow, air-filled bones, a trait it shares with modern birds. This adaptation would have made it more agile and less burdened by its size. It's another reminder of how evolution was already laying down the groundwork for the eventual rise of avian species, long before the first true bird took flight. So what do we make of this odd predator with a crested head and hollow bones? Dilophosaurus challenges our assumptions about early theropods. It's not just a relic of Jurassic times. It's a symbol of how much there still is to learn. Every fossil, every reanalysis reveals more layers. Behind the mystery of the twin crests lies a dynamic, evolving story that reminds us just how strange and wondrous real dinosaurs could be. Not all mysteries get solved. And maybe that's part of the allure. Dilophosaurus, the double-crested shadow of the early Jurassic, still keeps some secrets to itself. Chapter 14. The dinosaur that dug like a mole. When we think of dinosaurs, we often imagine creatures towering above the treetops, stampeding across vast plains, or stalking prey with deadly precision. But digging? That's a behavior we tend to reserve for mammals, badgers, moles, and prairie dogs. Yet here, tucked quietly into the fossil record, is a dinosaur that flips that notion on its head. Meet Orictodromeus, a creature that lived roughly 95 million years ago during the mid-Cretaceous period. Its name literally translates to digging runner, and it's not just a catchy label. Paleontologists believe this small herbivorous dinosaur may have been one of the first known burrowing dinosaurs, a discovery that challenged assumptions about dinosaur behavior and even their parenting strategies. At about 2 meters, 6.5 feet in length, Orictodromeus wasn't particularly large. Most of that length was tail, and its overall body mass would have been comparable to a large turkey or small dog. It wasn't intimidating. It didn't have claws that could shred flesh, nor horns for defense. What it did have, however, was something far rarer in the dinosaur kingdom: adaptability. And it may have carved out a niche not by dominating the landscape, but by diving beneath it. In 2007, paleontologists discovered a fossilized den in Montana that changed the game. Inside that den were 3 Orictodromeus skeletons, an adult, and 2 juveniles. They weren't scattered remains like you might expect from animals dragged in by scavengers. These skeletons were curled, preserved in lifelike positions, and crucially, found inside a sediment structure that bore all the hallmarks of a burrow. Rounded tunnels, chambers, compacted walls. The implication? These dinosaurs didn't just fall into a hole, they lived there. Why would a dinosaur dig? To answer that, let's consider the world Orictodromeus lived in. During the Cretaceous, North America was teeming with predators: dromaeosaurs, tyrannosaurids, and other quick, sharp-toothed threats. For a small herbivore like Orictodromeus, running might not always cut it. So instead, it may have gone underground, literally. The burrows offered shelter not just from predators, but from environmental stress, temperature extremes, seasonal droughts, even wildfires. But digging is hard work. Evolution doesn't hand out that skill without a price. So what in Orictodromeus's body suggests it was up to the task? Let's start with its limbs. The forelimbs were not massive, but they were unusually strong for its size, with expanded muscle attachment sites, particularly around the shoulders and upper arms. Its claws were curved and strong, adapted for breaking through soil rather than slicing prey. Meanwhile, its hindlimbs, while still built for running, had a stockier structure than most other small ornithopods. It wasn't built purely for speed. It was multisker. Then there's the skull. Orictodromeus had a blunt snout, which some paleontologists think may have helped it nudge through dirt. Its overall body was compact and flexible, allowing it to twist and turn within tight spaces. Think about that: a dinosaur adapting not for dominance or size, but for navigation in a world that most other dinosaurs never explored. And let's not forget the social angle. The fossilized family found in Montana suggests something potentially even more fascinating: parental care. we don't often imagine dinosaurs as doting parents. Hollywood has ingrained in us the image of giant reptiles, laying eggs and walking away. But more and more, we're seeing evidence that some dinosaurs nurtured their young guarding nests, possibly feeding hatchlings, even teaching them survival behaviors. The juveniles found with the adult Orictodromeus weren't hatchlings. They were old enough to have left the nest, but still young. That suggests they stayed with the parent for protection and care, possibly for weeks or months. If that sounds familiar, it should. It's a behavior we associate with birds and mammals. And in that sense, Orictodromeus begins to blur the line. It wasn't just a quirky dinosaur that dug holes. It may have been a socially complex, nurturing, highly adaptive species, one that tells us dinosaurs were far more diverse in behavior than we ever imagined. Imagine this scene: a Cretaceous forest, dense with low vegetation. Predators roam in the shadows. But beneath the earth, in a hidden tunnel, a mother Orictodromeus huddles with her young. Outside, danger passes unaware. Inside, life continues quietly and safely. It's not just a story of survival. It's a story of strategy. And it raises deeper questions. How many other dinosaurs may have burrowed? Could this behavior have been more common than we think, simply unpreserved due to the rarity of fossilized burrows? After all, digging doesn't fossilize easily. The fact that we even found one preserved den with skeletons inside is almost miraculous. There's also an evolutionary angle. Orictodromeus belongs to a group called Hypsilophodontids, a branch of small, fast-moving herbivores that are often overlooked in the dinosaur world. But what if they weren't just sprinting through the underbrush? What if some, like Orictodromeus, were burrowers, and others use different survival strategies we haven't even imagined yet? These aren't just biological oddities, they're clues to the diversity of Mesozoic life. Dinosaurs weren't just lumbering giants or terror-inducing predators. They were nimble, clever, sometimes shy, and often surprising. And perhaps most of all, they were experimental. Evolution tried all kinds of forms and functions in that 160 million year stretch. Some dinosaurs became flyers, some became swimmers, and some, like Orictodromeus, became diggers. It also redefines how we think of the rules dinosaurs played by. For a long time, paleontology painted dinosaurs into certain boxes. Meat-eaters hunted, plant-eaters grazed, big ones stomped, small ones ran. But Orictodromeus is a reminder that the real story is far more colorful. Behavior, like form, evolves. And in the shadowed world of burrows and tunnels, this small creature quietly rewrote what a dinosaur could be. In many ways, Orictodromeus didn't just dig into the earth, it dug into our assumptions. It forced us to look deeper, both literally and metaphorically. And it showed us that the most remarkable dinosaurs aren't always the biggest or fiercest, but sometimes the ones that changed the game by going underground. ChatGPT said. Chapter 15. The Speed Demon with Hollow Bones. When most people picture a fast dinosaur, their minds go straight to Velociraptor, or perhaps even T-Rex sprinting through the trees. But real speed, the kind built for sheer sprinting efficiency, belonged to a very different kind of dinosaur, one that looked more like a prehistoric ostrich than a scaly monster. This was Ornithamus, and it was a masterclass in lightweight design, speed, and evolutionary adaptation. The name Ornithamus means bird mimic, and it's easy to see why. With long legs, a slender neck, and a small head on a lightly built body, it looked more like a modern ostrich than a classic dinosaur. It lived around 70 million years ago in the late Cretaceous of North America, and it was part of a group known as the ornithomimids, often called ostrich dinosaurs. But don't let the bird-like build fool you into thinking it was delicate or timid. This dinosaur was an elite runner, possibly one of the fastest non-avian dinosaurs that ever lived. Its legs were long and powerful, built for high-speed movement across flat ground. The structure of its metatarsals, the long bones in the feet, suggests a build made for sprinting. They functioned like shock absorbers, allowing Ornithomimus to run smoothly and with great agility. Its stride was wide, its muscles lean and strong, and its overall body was streamlined. Some estimates suggest it could run at speeds of up to 40 to 50 kilometers per hour, 25 to 30 miles per hour, perhaps even faster in short bursts, making it one of the most agile dinosaurs of its time, unlike T-Rex or Allosaurus, which relied on brute strength. Ornithomimus relied on finesse. It didn't kill with jaws or claws. Instead, it avoided conflict altogether, outrunning threats and outracing danger. This was a dinosaur that survived by staying one step ahead. Literally, its skull tells another fascinating story. Unlike carnivorous theropods, Ornithomimus had a toothless beak. For years, this led to debate over its diet. Was it a herbivore? Omnivore? A specialist? The current consensus is that Ornithomimus was likely an opportunistic omnivore. It probably ate plants, small animals, insects, eggs, whatever it could get its beak on. Its beak was narrow and likely used for precise picking, almost like tweezers. This gave it flexibility in a variety of environments, from forests to floodplains. But then came one of the most remarkable discoveries of the past few decades: feather impressions. In 2012, paleontologists in Canada unearthed Ornithomimus fossils with clear evidence of feathers, not just vague impressions, but preserved structures showing downlight plumage and even wing-like appendages on the arms of some adults. Suddenly, the connection to modern birds wasn't just theoretical. It was real. Ornithomimus didn't just mimic birds in shape, it actually had feathers. This was groundbreaking. It revealed that feathers were far more widespread among dinosaurs than previously thought. And it raised new questions. Did Ornithomimus use its feathers for display? For thermoregulation? For mating rituals? It almost certainly didn't fly. Its arms weren't strong enough, and its body too large. But the feathers could have served multiple purposes. The wing-like structures, especially in adults, might have been used in courtship displays, similar to how modern birds spread their wings or puff up their feathers to attract mates. And the downy feathers covering its body, perfect for insulation. That suggests it may have been warm-blooded, or at least had a metabolism much closer to birds than cold-blooded reptiles. Another fascinating feature of Ornithomimus is its hollow bones, a trait it shares with modern birds and other advanced theropods. Hollow bones are strong yet lightweight, the perfect adaptation for reducing body mass while maintaining structural integrity. This is crucial not just for flight, but for speed. Less weight means less energy required to move quickly, and for Ornithomimus, every ounce mattered. Its arms, while not suited for flying, were long and mobile. Some paleontologists suggest they may have been used for foraging, perhaps reaching up to grab fruit or eggs, or even manipulating objects. That kind of behavioral flexibility, coupled with its physical agility, made Ornithomimus one of the most dynamic dinosaurs of the late Cretaceous. Its eyes were large, suggesting keen vision, and its brain was relatively well developed for a dinosaur of its size. It likely had good coordination and sensory processing, vital traits for an animal that relied on reaction speed and situational awareness. In fact, some researchers believe Ornithomimus may have been among the most intelligent non-avian dinosaurs. Not necessarily in the problem-solving sense of crows or parrots, but as a creature finely tuned to its environment. Let's imagine a day in its life. A herd of Ornithomimus grazes quietly near a riverbank, picking at ferns and small fruits, occasionally plucking insects off logs. Their heads jerk up at the sound of rustling brush. In the distance, a Dromaeosaurus creeps forward. The moment it crosses the open, the entire herd explodes into motion, not in chaos, but in coordination. Within seconds, they're gone, vanishing. into the tree line in a blur of feathers and dust. Predators didn't waste time chasing Ornithomimus. They knew better, but life wasn't without danger. Nesting season could have made them vulnerable. If they laid eggs on the ground, as birds like ostriches do today, they may have needed to guard their nests carefully. Those same wing-like arms could have played a role in protecting or shading eggs. It's even possible that, like modern radites, the males did much of the brooding. We may never know for sure. One of the most evocative ideas, though, is the image of a feathered ornithomimus fanning its arms in a dusty courtship dance, like a prehistoric bird of paradise, using color, motion, and posture to attract a mate. We don't have fossilized pigments from this species, but if its feathers were colorful, the possibilities are dazzling. In many ways, Ornithomimus is a bridge. It connects the ancient dinosaur past with the feathered, flapping present. It shows us that evolution didn't make a sharp break between non-avian and avian dinosaurs. It was a continuum, a blur. And Ornithomimus stands right in that blur. Not quite a bird, but not entirely a lizard either. We often think of speed as a simple trait, the ability to run fast. But for Ornithomimus, speed was the result of so many things working together. Hollow bones, long limbs, keen senses, a light frame, and behavior evolved for vigilance and quick decision-making. It wasn't a predator or a fighter, but a specialist in survival, built to outlast the chase, to stay ahead, and to adapt fast. That's why this bird mimic isn't just another footnote in the dinosaur world. It's a vivid, dynamic example of how evolution can push life to experiment with body plans, behaviors, and even entire survival strategies. And for Ornithomimus, speed was more than a trait. It was a way of life. ChatGPT said, Chapter 16, The Giant Claw with a Vegetarian Heart. Featuring Therizinosaurus, approximately 2,000 words. Imagine a dinosaur with claws longer than your arm, a pot-bellied torso, a beak without teeth, and a body draped in feathers. No, this isn't a monster from a sci-fi movie. It's Therizinosaurus, one of the strangest, most misunderstood creatures to walk the earth. It defies almost every stereotypical image of a dinosaur. It looked terrifying but wasn't a predator. It had fearsome weapons but probably didn't use them to kill. It was big, bulky, and armed, yet it was a peaceful herbivore with a heart set on leaves. When the first fossils of Therizinosaurus were discovered in Mongolia in the 1940s, they puzzled paleontologists. What they found were giant claws, some nearly 3 feet long, and not much else. These claws were curved and sharp, resembling scythes or swords. For decades, scientists had no idea what kind of animal they belonged to. The original theory? A giant turtle. It wasn't until later, as more bones were unearthed, that the true picture began to form. The animal was massive, up to 30 feet long, and its bones showed signs of a body built for bulk, not speed. It walked on 2 legs, like a theropod, but its hips, feet, and hands didn't quite fit the mold of a classic predator. It had a long neck and a small head, and when its skull was finally found, it turned out to have no teeth in the front of its beak-like mouth and tiny, leaf-shaped teeth in the back, the kind suited for chewing plants. Suddenly, everything changed. The giant claws weren't hunting tools. They were more like gardening implements. And this fearsome-looking dinosaur, it seemed, was a giant, gentle herbivore. That twist, the visual horror of those claws versus their true function, is part of what makes Therizinosaurus so unforgettable. The claws likely served multiple purposes. They may have helped pull down branches, strip leaves, or rake through undergrowth. They could have been used for defense, swiping at would-be attackers, like a modern sloth swings its long arms. And there's even a possibility they were used in mating displays or combat between rivals, like deer antlers or peacock feathers, but sharpened to prehistoric perfection. Its body was equally bizarre. It had a wide pelvis and a large, bloated belly, likely a sign of a large gut packed with microbes to break down tough plant material. This is common in many herbivores, but in Therizinosaurus, it's paired with features that scream meat-eater. Walking on two legs, grasping hands, and claws you'd expect from a raptor. It's like someone combined a sloth, a bird, and a T-Rex into one Frankenstein dinosaur. And yes, it had feathers. In fact, many of its close relatives in the Therizinosaur group were covered in primitive, filament-like feathers, and some had more elaborate plumage. While no direct feather impressions have been found with Therizinosaurus itself, the strong evolutionary link makes it almost certain that it was feathered too. These feathers weren't for flying. Therizinosaurus was far too heavy for that. But they may have been used for display, insulation, or even brooding behavior over nests. Its arms were also extraordinary. Not just because of the claws, but because of their length and mobility. Each hand had 3 fingers, with the middle finger bearing the longest claw. These arms were capable of reaching, pulling, and possibly even manipulating objects. Rare ability in such large dinosaurs. In terms of limb length and shape, they were more similar to those of birds than to most other theropods. Let's talk about its environment. Therizinosaurus lived in late Cretaceous Mongolia, a region that, at the time, was a rich floodplain ecosystem with rivers, ferns, flowering plants, and plenty of other dinosaurs. It shared its world with predators like Tarbosaurus, a close cousin of T-Rex, and smaller, faster creatures like Velociraptor. In this environment, Therizinosaurus likely filled a unique ecological niche, a large herbivore that could stand on 2 legs, reach high vegetation, and defend itself with devastating claws. You wouldn't want to pick a fight with it. While it likely wasn't aggressive, those claws could have done serious damage in defense. A single swipe might have been enough to injure or even kill a predator if aimed well. Its sheer size would have also deterred most attackers. It wasn't built for speed, but it didn't need to be. Standing as tall as a giraffe and weighing several tons, it was a lumbering wall of feathers and claws. But perhaps one of the most important aspects of Therizinosaurus is how it reshaped our understanding of dinosaur evolution. For years, theropods, the group that includes T-Rex, Velociraptor, and all modern birds, were thought to be exclusively meat-eaters. That idea held until dinosaurs like Therizinosaurus came along. Here was a theropod that not only didn't eat meat, but had fully committed to a herbivorous lifestyle. It showed that even within a group known for ferocity and predation, evolution could take a totally different path. It's as if a wolf decided to become a cow. Its discovery forced scientists to reevaluate the flexibility of dinosaur evolution. If a theropod could grow feathers, trade teeth for a beak, and swap killing for grazing, then the possibilities were wide open. It reinforced the idea that dinosaurs weren't static or simple. They were dynamic, changing, experimenting, just like mammals did after the dinosaur age ended. And from a visual standpoint, Therizinosaurus remains one of the most unforgettable dinosaurs ever discovered. Its strange blend of traits, monstrous claws, gentle herbivory, bird-like body, sloth-like posture, makes it almost alien. You could imagine it walking out of a fantasy forest rather than a prehistoric swamp. Yet it was real. It lived. It thrived. Imagine it now, slowly striding through the underbrush, its claws brushing aside leaves as it pulls down a branch to munch on. Feathers flutter in the warm breeze. In the distance, a predator watches, but hesitates. The claws are enough to give even the boldest hunter pause. In a world often dominated by toothy terror, Therizinosaurus carved out a different kind of power. One of strangeness, adaptability, and peaceful strength. It didn't need to chase prey to be extraordinary. Its uniqueness made it unforgettable. Chapter 16. The Giant Claw with a Vegetarian Heart. Imagine a dinosaur with claws longer than your arm, a pot-bellied torso, a beak without teeth, and a body draped in feathers. No, this isn't a monster from a sci-fi movie. It's Therizinosaurus, one of the strangest, most misunderstood creatures to walk the earth. It defies almost every stereotypical image of a dinosaur. It looked terrifying but wasn't a predator. It had fearsome weapons but probably didn't use them to kill. It was big, bulky, and armed, yet it was a peaceful herbivore with a heart set on leaves. When the first fossils of Therizinosaurus were discovered in Mongolia in the 1940s, they puzzled paleontologists. What they found were giant claws, some nearly 3 feet long, and not much else. These claws were curved and sharp, resembling scythes or swords. For decades, scientists had no idea what kind of animal they belonged to. The original theory? A giant turtle. Some thought the claws might have belonged to a bizarre swimming reptile. There simply wasn't enough fossil evidence to make a clear call. It wasn't until later, as more bones were unearthed, that the true picture began to form. The animal was massive, up to 30 feet long, and its bones showed signs of a body. Built for bulk, not speed. It walked on 2 legs like a theropod, but its hips, feet, and hands didn't quite fit the mold of a classic predator. It had a long neck and a small head, and when its skull was finally found, it turned out to have no teeth in the front of its beak-like mouth and tiny, leaf-shaped teeth in the back, the kind suited for chewing plants. Suddenly, everything changed. The giant claws weren't hunting tools. They were more like gardening implements. And this fearsome-looking dinosaur, it seemed, was a giant, gentle herbivore. That twist, the visual horror of those claws versus their true function, is part of what makes Therizinosaurus so unforgettable. The claws likely served multiple purposes. They may have helped pull down branches, strip leaves, or rake through undergrowth. They could have been used for defense, swiping at would-be attackers like a modern sloth swings its long arms. And there's even a possibility they were used in mating displays or combat between rivals, like deer antlers or peacock feathers, but sharpened to prehistoric perfection. Its body was equally bizarre. It had a wide pelvis and a large, bloated belly, likely a sign of a large gut packed with microbes to break down tough plant material. This is common in many herbivores, but in Therizinosaurus, it's paired with features that scream meat-eater. Walking on 2 legs, grasping hands, and claws you'd expect from a raptor. It's like someone combined a sloth, a bird, and a T-Rex into one Frankenstein dinosaur. And yes, it had feathers. In fact, many of its close relatives in the Therizinosaur group were covered in primitive, filament-like feathers, and some had more elaborate plumage. While no direct feather impressions have been found with Therizinosaurus itself, the strong evolutionary link makes it almost certain that it was feathered too. These feathers weren't for flying. Therizinosaurus was far too heavy for that, but they may have been used for display, insulation, or even brooding behavior over nests. The idea of a feathered, pot-bellied, claw-swinging herbivore is so far removed from the sleek, scaly predators of popular dinosaur imagery that it forces us to reimagine what dinosaurs were actually like. In many ways, Therizinosaurus offers a more accurate glimpse into the diversity of Mesozoic life than even the mighty T-Rex. Its arms were also extraordinary, not just because of the claws, but because of their length and mobility. Each hand had 3 fingers, with the middle finger bearing the longest claw. These arms were capable of reaching, pulling, and possibly even manipulating objects, a rare ability in such large dinosaurs. In terms of limb length and shape, they were more similar to those of birds than to most other theropods. Let's talk about its environment. Therizinosaurus lived in late Cretaceous Mongolia, a region that at the time was a rich floodplain ecosystem, with rivers, ferns, flowering plants, and plenty of other dinosaurs. It shared its world with predators like Tarbosaurus, a close cousin of T-Rex, and smaller, faster creatures like Velociraptor. In this environment, Therizinosaurus likely filled a unique ecological niche, a large herbivore that could stand On two legs, reach high vegetation, and defend itself with devastating claws. You wouldn't want to pick a fight with it. While it likely wasn't aggressive, those claws could have done serious damage in defense. A single swipe might have been enough to injure or even kill a predator if aimed well. Its sheer size would have also deterred most attackers. It wasn't built for speed, but it didn't need to be. Standing as tall as a giraffe and weighing several tons, it was a lumbering wall of feathers and claws, but perhaps one of the most important aspects of Therizinosaurus is how it reshaped our understanding of dinosaur evolution. For years, theropods, the group that includes T-Rex, Velociraptor, and all modern birds, were thought to be exclusively meat-eaters. That idea held until dinosaurs like Therizinosaurus came along. Here was a theropod that not only didn't eat meat, but had fully committed to a herbivorous lifestyle. It showed that even within a group known for ferocity and predation, evolution could take a totally different path. It's as if a wolf decided to become a cow. Its discovery forced scientists to reevaluate the flexibility of dinosaur evolution. If a theropod could grow feathers, trade teeth for a beak, and swap killing for grazing, then the possibilities were wide open. It reinforced the idea that dinosaurs weren't static or simple. They were dynamic, changing, experimenting, just like mammals did after the dinosaur age ended. Some scientists even believe that Therizinosaurus and its relatives might represent an example of convergent evolution, where unrelated groups independently evolve similar traits. In this case, Therizinosaurs developed herbivorous adaptations that mirrored those of sauropods and ornithischians. But they did it with a completely different starting toolkit: claws, bipedal stance, and bird-like features. Another layer of intrigue comes from its potential intelligence. While it's hard to measure brain power from fossils, some researchers suggest that Therizinosaurs had relatively large brains for their size. Combined with their sensory abilities, long necks, and complex feathers, it's possible they engaged in more complex social behavior than previously thought. Maybe they used their claws not just for feeding or defense, but in elaborate visual displays, or even territorial gestures. Imagine Therizinosaurus in its full glory, standing upright in a sunlit clearing, feathers rustling, claws raised not in aggression but in ritualistic display. Nearby, another individual mimics the motion. Are they rivals, mates, or just signaling peacefully across the plains? We may never know, but the clues suggest this was not a simple animal dot in a world often dominated by toothy terror. Therizinosaurus carved out a different kind of power, one of strangeness, adaptability, and peaceful strength. It didn't need to chase prey to be extraordinary. Its uniqueness made it unforgettable. Chapter 17. The spiky sentinel with a surprising brain. If you were to meet a Kentrosaurus face to face, your first thought might be Stegosaurus, but meaner. That's understandable. With its double row of plates along its back transitioning into long wicked tail spikes, Kentrosaurus looked like a creature built for war. But while it certainly had the looks of a prehistoric pincushion, this Jurassic herbivore is more than just spikes and armor. New research suggests it may have had surprisingly complex behavior and neurological capabilities for a dinosaur that has long been typecast as slow and dim-witted. Kentrosaurus lived about 150 million years ago in what is now Tanzania, part of a vibrant Jurassic ecosystem teeming with sauropods, early predators, and lush vegetation. Though smaller than its cousin Stegosaurus, averaging around 15 feet in length and weighing about 1 ton, Kentrosaurus was arguably more heavily armed for its size. Its body was lined with small plates that ran down from its neck to its mid-back. Behind that, things got pointy fast. Pairs of long, sharp spikes extended down its hips, with the final act being a muscular tail armed with even longer spikes that could be swung like a club. These spikes weren't for show. Paleontologists believe the tail of Kentrosaurus was incredibly flexible, and capable of delivering forceful, targeted strikes. The biomechanics suggest that Kentrosaurus could whip its tail side to side in rapid succession, creating a danger zone for any predator bold enough to approach from behind. And in the dangerous world of the late Jurassic, that was likely a daily reality. But the defense system of Kentrosaurus was just one layer of its survival strategy. Recent studies of its brain case revealed a shock. It may not have been as dumb as previously assumed. Traditionally, stegosaurs have been mocked for their tiny brains. Some estimates claim a brain the size of a walnut in an animal the size of a minivan. Yet Kentrosaurus seems to break the mold slightly. Its brain-to-body ratio was still small, but certain parts of the brain, especially those related to motor coordination and sensory input, were more developed than expected. This has led to a reevaluation of how Kentrosaurus may have behaved. Rather than being a slow, lumbering, dim creature, it may have had better balance, more refined muscle control, and keener sensory awareness than its reputation suggests. It had large inner ear canals, which may have helped with equilibrium and coordination. This would be essential if it needed to use its tail spikes precisely in a defensive scenario. What did Kentrosaurus eat? Like other stegosaurs, it was an herbivore. Its small head had a beak-like mouth suited for nipping low-lying plants. It likely fed on ferns, cycads, and horsetails, all common in the Jurassic landscape. With no complex chewing mechanism, it probably swallowed rough vegetation whole, relying on its large gut to ferment and digest plant matter slowly. Fossil evidence doesn't show advanced teeth, but it does suggest a digestive system adapted to processing bulk. Despite this simple feeding method, its skeletal design implies some mobility in the neck, allowing it to feed at different angles. This, coupled with its size, might have helped Kentrosaurus exploit vegetation other herbivores ignored. Its social behavior is still debated. No definitive evidence shows herd structure in Kentrosaurus, but bone beds containing multiple individuals suggest at least occasional group living. If Kentrosaurus did move in small groups, the tail spikes would have created a formidable wall of deterrence against predators like Allosaurus and Ceratosaurus. In this sense, it may have relied not just on armor, but on collective defense. Another surprise comes from the arrangement of its spikes. Unlike Stegosaurus, whose plates may have been used for thermoregulation or display, Kentrosaurus's armor seems purely functional. Yet, some scientists speculate that the symmetrical, orderly rows of spikes may have also served a visual purpose. In the dense Jurassic forests, a flash of those sharp, glinting spikes might have been enough to warn off predators or impress a mate. One mystery that continues to puzzle scientists is the function of the hip spikes. Positioned along the sides of the rear torso, these spikes would have been difficult to aim or control like the tail spikes. Were they passive armor? Or did Kentrosaurus have enough muscular control to flex its torso slightly, shifting those spikes defensively? The biomechanics aren't clear, but their presence certainly added another deterrent layer. Interestingly, fossil trackways from related stegosaurs show that these dinosaurs weren't as plodding as once believed. Their gait, while not fast, was steady and deliberate. This fits with a lifestyle where endurance and stability were more important than sprinting. Kentrosaurus didn't need to run. It was a walking fortress. The sensory adaptations mentioned earlier might have also played a role in communication. While we have no direct evidence of vocalizations, the inner ear structure suggests that Kentrosaurus may have been sensitive to low-frequency sounds. This opens the possibility that they communicated through low rumbles, foot stomps, or other vibrations, a prehistoric Morse code echoing through the undergrowth. Even the tail of Kentrosaurus has sparked artistic and scientific debate. Mounted skeletons and paleoart often depict it dragging on the ground, but recent evidence suggests otherwise. The tail vertebrae were robust and articulated in a way that gave it significant lift and motion. This means Kentrosaurus likely carried its tail elevated, poised like a scorpion's, ready to strike. In essence, it was always cocked and loaded. To understand how effective those spikes were, consider that puncture wounds from even a single strike could disable a predator. Some paleontologists believe a direct hit could penetrate deep muscle tissue or even bone. The psychological effect alone, knowing that a wrong move could result in a painful injury, may have kept many predators at bay. In this light, Kentrosaurus wasn't just surviving. It was actively shaping its place in the ecosystem by making itself too costly to attack. In the end, Kentrosaurus was a blend of brute design and subtle intelligence. Not the brainless pincushion of old textbooks, but a well-adapted, potentially social, and highly defensive herbivore. It didn't dominate with size or speed, but with the careful balance of evolution's best defense strategies: armor, awareness, and attitude. Chapter 18. The Swimmer with Sails and Surprises in the World of Dinosaurs. Appearances can be deceiving. Some look like monsters but were mellow. Others seem dull until their fossils whisper tales of evolutionary genius. And then there's Oranosaurus, a dinosaur with a back like a sailboat and the build of a duck-billed herbivore. For decades, it puzzled paleontologists. Was it a desert dweller or a swamp stalker? Did it store fat like a camel or display its sail like a peacock? Was it a sluggish grazer or something more nimble, more surprising? The truth, as always, is far more fascinating than first impressions. When people see reconstructions of Oranosaurus, their first question is usually, is that a Spinosaurus? It's not, but the confusion is understandable. The tall neural spines running along its back form a sail or hump-like structure, just like Spinosaurus. But Oranosaurus wasn't a fearsome carnivore. It was an herbivore, gentle, even graceful in movement, and far more enigmatic than its toothy cousin. It roamed what is now North Africa during the early Cretaceous period, around 110 million years ago. And while it wasn't the biggest dinosaur on the block, it was certainly one of the most visually distinctive. Discovered in Niger in the 1960s, Oranosaurus nigeriensis immediately threw scientists into a debate. Its name, derived from a Tuareg word meaning brave lizard, suited the dramatic look of the animal. At about 24 feet long and weighing in at around 4 tons, it had the build of a hadrosaur, the duck-billed dinosaurs, though it technically belonged to an earlier group known as iguanodontians. Its mouth ended in a wide, flat beak, ideal for cropping vegetation, and it had a battery of teeth toward the back for grinding tough plants. In short, it was a grazing machine. But what really set Oranosaurus apart were those spines. Stretching up to 3 feet long, they protruded from the vertebrae along its back and tail, forming a sail-like structure. At first glance, this feature looked like something from Dimetrodon or Spinosaurus, animals whose sails were often linked to thermoregulation or visual display. But the exact function in Oranosaurus? Still up for debate. Some paleontologists propose that the sail was a heat management system. In the hot floodplain environment where Oranosaurus lived, such a sail might have helped it cool down by dispersing heat through blood vessels that ran along the spines. Others suggest the opposite, that it stored heat, helping the animal warm up during chilly desert nights. A third theory? It wasn't a sail at all, but a fat-storing hump, more like a camel's than a sailfish's. This interpretation turns the spines from a heat exchange structure into a survival tool, possibly storing energy during dry seasons. Then, there's the more flamboyant idea that the sail was all about show. Brightly colored, perhaps even patterned, it might have been a visual signal to impress mates, intimidate rivals, or help individuals recognize one another in herds. Like the tail of a peacock or the mane of a lion, it could have been less about biology and more about charisma. Whatever the function, one thing is clear: this was no ordinary back. And the mystery only deepens when you consider the animal's limbs. Unlike some of its relatives, Ouranosaurus had unusually long, slender forelimbs, suggesting it may have spent more time on all fours than previously thought. Yet, it could still rear up and walk bipedally when needed. This dual-mode locomotion made it versatile, able to browse both high and low, walk long distances, and maybe even gallop in short bursts. Its hands were also worth noting. Like a Iguanodon, it had a thumb spike, a keratinous cone likely used in defense or perhaps in interspecies combat. The rest of its fingers were suited to weight-bearing, suggesting those front limbs weren't just for show. They helped support its weight while walking or grazing, especially in wet environments. And speaking of environments, Ouranosaurus didn't live in some dry, barren desert. It roamed lush river deltas and tropical floodplains teeming with life. Fossils show it. Shared its world with massive sauropods, agile theropods, crocodile-like reptiles, and early flowering plants. It lived in a dynamic ecosystem where survival meant adapting to shifting resources, seasonal floods, and possibly predatory threats from creatures like Suchomimus, another sail-backed dinosaur, but one with a mouth full of teeth. So was Ouranosaurus semi-aquatic? There's some speculation. Its long tail and potentially flattened feet hint it might have waded or even swum in shallow waters, much like a modern hippo. Its diet probably included soft aquatic plants as well as tougher shrubs and ground vegetation. It's easy to picture a herd of Ouranosaurus standing knee-deep in a swamp, pulling up ferns with their beaks, sails rising above the reeds like flags in the breeze. And this brings us to a deeper point: what Ouranosaurus teaches us about dinosaur diversity. For a long time, dinosaurs were painted in broad strokes: meat-eaters with sharp teeth, plant-eaters with plates or horns. But Ouranosaurus is a reminder that real evolution doesn't stick to stereotypes. Here was a dinosaur that blended traits: spines like a predator, a beak like a duck, limbs like a quadruped, and a lifestyle potentially at the water's edge. It challenged the image of dinosaurs as rigid, scaly creatures locked into simple roles. Like Therizinosaurus, which wielded claws like scythes but ate leaves, or Ankylosaurus, a living tank that spent its life munching on ferns, Ouranosaurus defied categorization. It was part of a grand experiment, nature trying every combination of traits to see what stuck. Even the story of its discovery is a reminder of how much we still don't know. For decades after its initial find, Ouranosaurus was known mostly from a few skeletons. It didn't make many headlines. It wasn't the star of Hollywood films or flashy museum displays. But as paleontology expanded and new techniques emerged, from CT scans to isotopic analysis, the quiet mystery of Ouranosaurus came back into focus. Now, scientists are re-examining its bones for signs of growth patterns, stress fractures, and vascular pathways that might reveal more about its life. They're looking at the microstructure of its sail spines, analyzing its beakwear for diet clues, and comparing it to both earlier iguanodontians and later hadrosaurs. In doing so, they're painting a richer, stranger picture of this dinosaur, one that's still evolving with every new fossil find. In the end, Ouranosaurus might not have the killer reputation of T-Rex or the cinematic fame of Velociraptor, but it earns its place in the Hall of Iconic Dinosaurs for one simple reason: it surprises us. It looks like one thing, acts like another, and hints at a lifestyle that breaks the rules. In a series dedicated to surprising truths about famous dinosaurs, what better note to end on than a creature that shows us just how weird and wonderful the age of dinosaurs truly was? Because sometimes, the most remarkable dinosaurs aren't the ones with the biggest teeth or the fiercest growl. They're the ones quietly wading through ancient swamps, sails glinting in the sun, challenging everything we thought we knew.